Ma'am, good morning. Ma'am, good morning. We can start the session. Will you please introduce the speaker? Meeting, please.
Yes, sir. Good morning, all participants, organizing members, and keynote speaker. I, Dr. Sunita Dhingra, from Department of Computer Science and Engineering, UIET, MDU, Rohtak, Printing and Design, to the Faculty Development Program on 3D. Good to see you all again and hope all of you are good. Our session is about 3D printing for designers and entrepreneurs. I am extremely privileged to have the opportunity to address our speaker, Dr. Mir Irfan ul Haq, who is going to continue this session. He has previously worked with the Research and Development Wing of Mahindra and Mahindra. He has carried his PhD in the area of tribology for 7 years, actively involved in teaching and research for the past field of materials, tribology, and 3D printing. He published around 25 research papers in SCI and Scopus Index journals. Moreover, he has been awarded several research grants for various projects from different agencies like DST and NPIU AICTE. Dr. Mir Irfan ul Haq is currently working as assistant professor at Mechanical Engineering to keep the audio and camera off. If you have raised all participants any query, put them in the chat box only. We will discuss all the doubts at the end of the session. I would like to invite Dr. Haq to continue the session and share valuable knowledge. Sir, please.
Thank you, ma'am. Thank you, ma'am, for this introduction, and thank you, Dr. Manish, for we have in the area of 3D printing. So I will just share my slides. Kindly let me know if there is some issue. Ma'am, are the slides visible?
Yes, sir, it's visible. Please.
Yes, sir. Yes, that.
Faculty at School of Mechanical Engineering, Shri Mata Vaishno Devi University. So I have chosen the topic by designers and entrepreneurs because I think the future is of entrepreneurship, and 3D printing has a role to play, and we will see how 3D printing can revolutionize designing as well as entrepreneurship. Content in this presentation, it belongs to the will be their respective intellectual property owners, and it's here used just for educational purposes. And part of this presentation also includes research work of our group, which is either unpublished content or under review or work in progress. So outline, I will be briefly going through, I think this is day 3 of this. The basics of 3D printing, but just to make a background of what we will be discussing, how 3D printing can help in design process, I will be going briefly through the basics of 3D printing. Post to that, we will see how 3D printing can help in design process and how 3D printing can aid in entrepreneurship. I'll be discussing with you some sample projects which we have carried here at SMVDU. Some case studies will also be taken up. So by now we know that of manufacturing in which we build at 3D printing is the part layer by layer, and directly we are able to somehow develop a physical part from a CAD file or a digital file, and the part is being built layer by layer, and there is little bit of post processing involved. So I'll be discussing in future slides some details into it. So the part complexity with which additive manufacturing or 3D printing can it's any other conventional processing. You see this. 1 minute. So if you see this complex part, we can't imagine this building this part by any conventional process, and there will be a lot of material which will be wasted if at all it is possible. And so material saving, part complexity which it can handle, the speed with which it can print is also remarkable. Part quantity, suppose you can give you can have a coffee, or you can go home, and at the end of the day you will have the part in your hand. So it is economical, and we will have some will show you some slides how it is cost effective. And contrary to the subtractive manufacturing, in which we start from a material like this, and then we remove the material from the part, and we reach at the object like this. So there is a lot of wastage involved. While as in case of additive manufacturing, we use the material in different forms, maybe in powder form, liquid form, or then the wastage is very less. So one more aspect of this 3D printing is that it handles complexity, and that too the complexity is with no additional cost. If you look at this graph and see the conventional manufacturing, if you include if your design is complex, more complex the design becomes, more will be the cost. While as in case of additive manufacturing, the complexity does not alter of the product. So that is how in designing you will see that, suppose you are interested in making very intricate shapes, or there are some complex internal geometries which are very difficult to produce by conventional manufacturing processes. So this technology of 3D printing is having the capability to handle complexity for free. So I think the types of 3D printing, you must be aware by the types of machines, in which one is the powder based, that is the base material is powder, and liquid based, in which the base material is a liquid, and while as for solid based there is a third category. In the powder based, which is basically used in case of metallic printers, we call it selective laser sintering. And in this powder bed is a layer of powder is put on the table, and a laser comes and sinters geometry as per the data of one of the layers. What 3D printing actually does is that, suppose I am interested in printing this cup. So suppose I make the CAD file of this cup, and then STL format actually saves this data, CAD data, in the form of layers. Suppose the first layer of this cup would be just a circular one, and if you reach to the fifth or sixth layer, there will be some part of this handle. So the different layers will be printed, and depending upon the movement of the laser, one of the layers will be solidify, and the powder bed will move downwards, and another powder layer will be spread on the bed, and the laser will move according to the data of the second layer, and consecutively the part will start building up. The issue with powder based is that handling powders is very difficult, and the powders are very costly. That's why metallic 3D printing is little bit that's why you don't see it in many labs in a country like India, or in labs like ours. Liquid based, we have two basic common types. One is the fuse deposition modeling. I'll be discussing that in detail in next two slides. Stereolithography is basically, we have a I would say a liquid pool in which which is basically photosensitive, and laser falls the liquid moves down on that, and then you solidify another layer of the liquid, and that's how the part builds up. Whereas in case of your laminated object manufacturing, we have the material in the form of layers, and the layer is in the form of sheets. The first sheet is cut in the form of the first geometry, suppose the circle. Then the new fresh sheet is allowed to get attached to the if you starts building up. If you have seen, many of the labs in India now have this fuse deposition modeling, and it's very economical also to buy this, in which basically we have an ABS spool, or typically it is this technology is suited for your polymeric materials, in which the material is supplied in the form of a filament. Constantly in this the driving motor extruder. The extruder is at a slightly at a higher temperature, so that the material which is in the form of this was till now it was in the form of it was in a solid state. Post to that, it becomes it gets converted into a semi-solid semi-liquid state, and in the semi-liquid state, as per the data of a particular layer, and drops the first layer on the base plate. The base plate is also at a higher temperature. So layer by layer, the part starts building up, and by cooling of the semi-liquid polymeric material, the part solidifies and starts building up. I have an AV on this. I think since this course is a virtual one, so I have made a video of the 3D printer. Is this video
no, sir,
visible?
at all. First of all, you have to stop this presentation, then start the video itself.
1 minute. Now it is visible.
Yes, sir. Yes, sir. Now it is visible.
Thank you. Thank you. So this is a conventional fuse deposition method 3D printer, in which we have, these are two extruders in which the material is being supplied through this nozzle here. Converted into a here we have a heating a liquid semi-solid state, and then we deposited on the base plate. The red one is the base plate, which is at a slightly higher temperature, and you can see the first layer being printed on the plate. So this is the spool through which the material is being supplied. This is a polymeric material, probably polylactic acid in the form of a filament. And you can see how this base plate can move in the Z then the extruder has the capability to direction. So once the first layer is print to move in X and Y directions, so it will move in accordance to the data saved in the STL format for a particular layer. So we have a provision in which we can change different parameters in this machine. Say, for example, the bed temperature we can vary, because the temperature of the bed will actually, affect the bonding of consecutive layers one over the another, which will ultimately have an effect on the mechanical strength of the development. Change the change thickness, we can change the infill pattern. I will show you, those images are with me, how we can change that, what I'm talking about. And we can change the infill density also. So depending upon our application and depending upon the material we are using, we can select the parameters, and I will show you in the consecutive slides what we have done on this simple machine. So this is used. You can see some of the small parts, how a 3D printer works, right, which we have developed in our labs and our students have printed. So the nut and bolt, which has been printed by 3D printer. See, the part has started building up. This is the material. So this was about fuse deposition modeling, and I will be talk to fuse deposition modeling because it's a cheap technology and it is viable for I would say small entrepreneurs, small designers who are working at a very small level. So the compatible materials with 3D printing in general, we can 3D print poly
Sir, please unmute yourself. Irfan sir, yeah.
Yeah. So
Yeah, no.
What was the previous slide? I was audible. Can anybody tell me? When I was talking during the video, you understood that? Okay.
Yes, sir.
3D printing, all compatible materials like polymers, metals, only polymeric materials, ABS, composites, they can cellulose, nylon, can be printed. How materials of this category by composites by this fuse deposition method, and a lot of often nano direction, wherein the composite or a composite material in which some microfiller is used, the extruder of and the extrusion temperature or a composite by 3D pressure. Temperature of the extruder has to be something. The area of 3D printing which is a new and disruptive one, and the area of nano or the nanotechnology. So if you are able to augment both the technologies and both the fields, and in design also, this is a field where future research can be done. So I think about that, but I will briefly touch upon this. What just you can change the bed temperature, which in this machine, the model, the nozzle dia can be changed at different temperature, and change. You can change the nozzle will give a different, which is important is that how you build result altogether, different mechanical strength build the part. Suppose we have this cup. This come to my mind is that it can be this. So I'll start building flare. And second orientation could be like burst. On the geometry and the design of the second, third, fourth, fifth, and like this part, you have to choose that what should be the build part orientation for the 3D printing the part. It would be okay, but if going, because if I build it like that ahead, the part may start. I have to foresee that the metal maybe later removed, but if the geometry is to be while work needed, so that also, and layer thickness, feed rate, other raster width, infill pattern, and raster angle. That I will in Jammu. The temperature here would see the environmental factors will play a part. If I'm printing, so something, and if I print it in Leh or that will affect the mechanical strength. Representation, how layer thickness is an important parameter. See, we are printing, choosing the layer thickness. If I important because number one, I want the part geometry to be captured perfectly. But that would actually increase the time to print the part. And having a layer thickness, thick layer of per layer, if I print thicker layers, that may have an effect on capturing the geometry, overall strength of the part. The bind of the consideration in this, and I will show you parameters. The other process, what other in this layer thickness and effect of parameters, which are suppose honeycomb structure. It could be top out infill turn, octa 1 3D honey line grid rectilinear call strength and infill density. See, print it at 40% density. It looks like this if it is in the density of infill pattern. So moving further, if you see build the part, that is important. Number two, layer thickness, that I also explained. and one more being printed. So you can see how the printing starts. That is one. What is the contour width you are doing? That is another parameter. The this, so that is also important. Number of, the air gap between two these lines of print, so important. So if you change these as an end mechanical strength, what effect it will have will affect the geometry, that. So one drawback, or I printing would say one issue with this fuse deposition, it layer by layer, but the subsequent gradient, there are what we call thermal contraction. More maybe duration, and that thermal contraction leads to bending. To suppose if I print some part in winter, warping, and that may, damage part, or the product which will be damage your part, or there will be some portions of the damaged. So that is an important consideration. Slide, there are different 3D printing costs, which suppose categories is high, while as post tooling costs, setup costs. If you see, in case of 3D processes, basically due to printing much lower than the less involvement of tooling and less real wastage, and less is COVID human intervention. So if some technology is there which is having able to run our industry or our factory, you will be amazed to. So we are able to meet the deadlines. That